So as usual, I already got started on this before I started the camera up. But I'm going to finish this step and maybe I can get a little more of this after. So I little change of plans here, and that's part of why I got going without the camera. I was originally going to do a shelf back here and then turn the end down and have a cap come up over it with a nut on the bottom. And then I thought about it. I want to do an inverse design because I want to get the blade closer to the end of the whole thing, so when it's in the middle it's at the lower point. So what I'm going to do here is I'm drilling a larger hole up the middle and I'm going to bore this out. And the slitting blade will set upon this edge here at the bottom, which I've already faced that off good and clean. And then what I'm going to do, the cap will have a stud that goes up inside that is turned to the inner diameter of the blade, so, which this is a 1-inch bore in the blade. So it'll be probably the diameter of this on the outside, the bottom of the cap, which I think it's 1 1/4 on that. And inside will be 1 inch to fit that nice and snug. You just want a nice slide fit, but nothing more than that. And then I'll drill a small hole up the middle and I'll thread up in here, and the bolt will go up and just tighten up on there, and that'll allow me to fit. I'm going to have about a 1/2 inch of range in there, so it'll go all the way down to fully closed, which will let me to run the real thin ones. And I can go up to a 1/2 inch, which I'll probably never go close to that. I think that probably the most I'll go is about a 1/4 inch, but I figure I'll make it with the extra capacity, just in case. So I'm almost done drilling this. Just got a little bit more I'll finish up here. And that looks like my mark right there. So next I'm going to slide this out of the way, and I'll start setting up for the boring bar, get my drill bit out cleaned up, and we'll go into the next operation here. So I'm going to start running in with the boring bar here, and right now my measurements are just roughed in. I don't have an exact diameter for the inside, so I'm going to do probably about 2 passes, and then I'll measure it and get everything tuned in, so that I know that the DRO is reading what's actually there, or at least within a tolerance of it. So now I should be able to get a good measurement in here. Okay, so now I've got to get my measurement in here. So 0.759. Okay, so now I have that set in the DRO, and as long as I don't change anything, I should be accurate out to the end within reason. The last bit, I want to stop just a little short and do a final measurement at the end, because sometimes you get a little bit of drift, something shifts just a little. Always a good idea to check right on the end. Okay, so now I'm going to turn my feet up a little bit here until I get close to the end. When I do measurements, I usually do a fine pass, just the one prior to the measurement, so that I have a good smooth surface to get a reading on. You can see where I'm looking here, the camera angle, but I'm actually, when I'm running in, I'm not watching the DRO. I used to, but now I've got a dial indicator down here. Maybe I'll see if I can get the camera down to show that. So by the carriage, I've got this dial indicator. And what I'm actually reading for, I have this preset for the stop point, and as soon as I see it move, I hit the disconnect on the drive. Shut sound off there a sec. Anyways, so one thing I've noticed, I just started doing this like a couple of days ago. I've always, prior to this, I've used the DRO. But it's you really got to pay attention with the DRO, reading the numbers when it counts down to 0 to hit it right. It's really easy to lapse on it and overshoot. This is a lot easier. You just watch till it comes close to the point, and when it comes close, you watch the needle. As soon as that needle moves, you shut it. Now, I'm not sure what most people do here, if they just try and stop it on the needle. What I very quickly realized is that you have a certain amount of reaction time. And I do a couple of practice ones to know what my reaction time is going to be. What I'll typically do is I'll have the tool off the work. I'll do a couple of dry runs and trigger at the point where I see the needle start to move, and I'll note where the needle stops, and I'll look for the maximum point that I overshoot, that I go up, and whatever that maximum is, I'll set my carriage to that point, and then I'll dial in my actual stop point with the tool using the combination slide. So my reaction time stop, the worst reaction time stop that I get, will put me right on the mark where I want. And doing it that way, I found I can, with even a fairly fast speed, I can hit within about 0.3 millimeter with relative ease, as long as I'm paying attention to what I'm doing. Deviation of reaction time should be a lot smaller than the reaction time itself, so it's a lot better doing it this way, I think, than just looking for a 0 point and having a little extra and hoping for the best. This way I can get very close, and the last bit I just got a little bit of cleanup when I'm all done at the bottom of a cut. So I'm going in 3/4 of an inch, which if I have the maximum 1/2 inch cutter on there, that'll leave me a 1/4 inch lead in on the centering piece, so it doesn't move around. It keeps everything positioned accurately. This fine point boring bar is really slow, but I don't have a broad tip that's small enough to fit, so speeding this up a bit. See if we can get you a different angle on it so you can see what's happening here. And again, we can speed this a little bit up. Another guide I'll use is the position of the handle here, because that's always going to come up within a degree or two of the same spot every time. The little bit that wouldn't be would be a little bit of gear lash, but it's probably only about 1 degree or 2 degrees. So I take note of where that handle is on the last rotation. I watch the distance, and then when I see that handle come up the last rotation and I see it in a certain position, I know it's about to hit. and that's when I really pay attention to the gauge. So that just helps me. So I'm not just watching a gauge that's not moving and all of a sudden it goes. I have some indications that lead me to know about when it's ready. So I'm in a ready state to trigger it almost instantly as soon as that needle starts to go. So finally, we get to see a little bit of the action in the hole here. Sorry about the camera view in the first section where the tool post was kind of in the way. Just didn't see it till after I filmed. Here I'm taking the final measurement and then entering in the current data into the DRO so the final measurements are accurate. At the end of this pass, you'll see me move the cross slide to clean up the bottom of the bore. This is the final pass and a shallower depth of cut to hit my final mark. I'm also cutting at a slower speed on these last two passes to give a better finish, so not as many chips. So that last one I did a spring pass on, because it is a boring bar that's extended a good bit, so there is a little spring on it. And it looks like it's dead on right now, right on 1 inch. So I'm happy with that. That's right where I want it to be. Okay, so we're going to start the pilot drill. There's already a little point down there from the previous drill for the bore, but it's kind of shallow in pitch. I'd rather have a proper pilot hole down there to start the next bit.
So the steel I used for this project came from an old scrap shaft, and I'm not sure what kind of steel this was made out of, but I have to say the high-speed steel tools really struggled to cut this. The carbide had no problem whatsoever, but things like drilling the pilot hole and later on when I tapped this hole, it gave me a lot more difficulty than I expected.
Okay, now I gotta figure my depth here. Okay, so I did some measurements, and it looks like from the bottom of the bore here, where the bit's gonna touch, to the full depth that I need for the drill hole is going to be 22 millimeters. So now I know what I'm gonna do. So I've got this set so it touches off where I've got 10 millimeter on the quill markings, so I'll run it up to 32 and then I should have my right depth. Yeah, we'll probably run just a little faster. Yeah, I think we're going to use the water on this. Get some cooling in there. Probably not going to splash much on this because it's a low RPM, but and that should give me my depth. Okay, so now I'm ready to tap this, and this is the bolt that or Allen screw that I'm going to use to hold the cap on in place. Go in like this. It is a 3/8 National Fine.
The start was difficult, so I tried power tapping.
So now I'm ready to tap this, and I'm going to use the tailstock to at least get this started. Try and get it square, and I'm going to use the jog button to for the feed. This seems to be going a little tighter than I expected. I've got the tailstock loose so it can slide back and forth. I do have a start on this, so and it should be square at this point, so I may do this by hand from here on out, just so I can get the feel, because I don't trust doing it on power the way that's tightening up. My chart says the drill was right, but it seems a little tighter than it should be. These are old straight shank or straight flute taps. I've had these since I was a little kid. I really need to get a set of spiral flute taps for doing this machine work. Part of this may be the steel. This is an actual shaft steel. I haven't worked with this too much, but it may just be something that, you know, cuts kind of hard for tapping. But I still kind of think that the hole's a little small. I definitely don't want to do this by machine, not with this tap anyway. Not the way it feels. I can tell right now it wouldn't take much at all to snap this. I changed my cutting oils. I went to a thicker, heavier cutting oil for the tap too. That seems to help a little bit. One I was using, it was too light. Can't really see it in the video, but what I'm feeling, it feels very sticky at the bottom when I'm trying to turn this. It's not so much cutting force, it's like a lot of friction, like it's being squeezed. Okay, so I think I'm pretty close. Might have one or two more turns. going to check with the Allen screw and see what it looks like. I'm going to do this so it insets in the cap. I think I'm going to have to go quite a bit more actually. I may need to get a bottoming tap because I think what's happening a little, like this is a standard one, so it's about 5 threads that taper down, and it's not allowing the screw to go all the way to the bottom because of the taper. Because I should be almost at the reach right now, and the screw is going quite a bit shorter of what it should be. Let's see if I can get it close enough. Either that or I change the design of the cap and I don't do an inset. Okay, so I did actually manage to get this to go all the way down enough. I went off camera because I was running into some challenges. But ultimately what I ended up doing is I put the drill back in the tailstock and re-drilled another 3/8 or so of an inch in there. Where it's a chuck and tailstock, they're very accurate. So I really wasn't worried about wiping out the threads from running the drill in. As long as you don't not full of slop in there, you should be able to go right up the center of your threads with the original drill that you center drilled for. But what is a concern is coming back out because, and the drilling itself, because you're got all the chips from drilling that want to come out. So I had to do a lot of little very short cuts, just go a millimeter or two, back it back out, take the air gun, blow everything out, go back in and repeat that a number of times till I got to the depth that I wanted. So I decided not to do that on camera. This metal appears to be very sticky with the tap. I'm not sure what metal it is. I've never tapped with something that sticky and steel before. I'm a little surprised. But the depth issue is actually my mistake. I should have drilled in further to begin with. I forgot to account for the lead in on the tap, where this is just a standard tap. It's not a bottoming tap. I'm going to see if we can show this here. But if you look, the threads, it's ground down at the end, so they don't cut all the way out to the full thread depth down here. So your bolt can only come up in the hole to about that depth. Once it goes beyond that, it starts getting squeezed in because the threads aren't cut all the way to the point where they come out on the bolt. So that's what happened, and it's close to about 1/4 inch. So that was my error. But it'll show now that this does go in. It goes in all the way. In fact, I actually went a little beyond what I need on it. But I figured it'd be on the safe side after that. So that'll hold the cap on. So what I'm going to do here is this will be the cap that goes on. The Allen head will be sunk into the cap. So we're going to have about 1/4 inch or so. I think it's a little over. It's probably closer to 3/8. Whatever the height of that cap is, that's how thick I'm going to make the flange on the cap, and the rest will go up inside.
So now the main body of the slitting saw Arbor is complete, along with this video. In part 2, we'll make the cap and mount everything on the mill. If you've made it this far, I hope you've enjoyed watching this video and found it entertaining or educational. If so, please consider hitting like or subscribe. It does help give me incentive to continue producing more. Thank you.